Oh, you can. So, ask me a question, Gordon, during the session, then you can just type it into chat, just like you've done there.
Yeah, I'm going to mute myself. I think I know.
Yeah. So, what I'm going to do is I'm going to
mute so it's not in the background.
Okay, all right, lovely, thank you. So what I'm going to do is have certain times where you'll be able to. Actually, it doesn't matter when you ask the question, but sometimes when I'll address the questions that have come up on the chat. So if something comes up during the session, then you can just use that play to ask the question that you want.
Yeah, actually, wasn't right. I'm just going to watch and try and learn and pick up. It's for mainly for others, so I will be right. But I will try to learn.
You may decide it's too easy for you. You know, it's entirely up to you, but that's fine. It might be the session next week and the one after that might be more appropriate, but certainly welcome to sit and watch. Yeah.
Yeah.
Okay, you're welcome. All right, let's go to students list. As well. Early. Use to. During this. I can all hear me, so I can see on and Lee. Wait to see how many points come on. So we've got until 6 o'clock. So we'll have a cup of tea or whatever at 6 o'clock. Okay. Hello.
No.
Oh, hello. Is that Lee?
It is, yeah. You okay?
Okay. Yeah, I'm fine. I'm just going to start at 6 o'clock. But if you have questions, use the chat menu.
Really?
Yeah. Can you see it?
Yeah.
If you just type in hi, then I'll know it's working.
I should.
Oh, lovely. Yeah, I can see it. Thank you.
Okay.
That was weird. Yeah. Yeah. I have now. If you can, in the queue, if you could just write yes. All right, can you hear me? And if you say yes, thank you, Gordon. Thanks, Chris. I will. Great. Okay, I think I've got everyone at 6 o'clock. Now, participants may join us. We're going through the session, and that's fine. Close now, so I won't be able to see any chat messages that you send me yet. But sometimes I'll ask you if you have any questions to type them into chat, and then I'll be able to get that menu back up. Okay. Hopefully you can all see the screen, which is the Algebra Workshop 1 Expressions title page. Please make sure that you have something with and something to write on, because I'm going to be asking you to do some questions. Obviously, you can hear me, so that should be fine. If I'm a bit quiet or a bit loud, then just give me a shout in chat. And chat every now and again and make sure that you can hear me okay. All right. Okay, first of all, this is one of 3 sessions, and they'll be on Thursday, the next 2 Thursdays after this one, all 6 p.m. to 7 p.m. And they're all on basic algebra. So today's workshop is on equations. Okay, so and next week we're going to look at equations, and the week after we'll look at surds, indices, and logarithms. All these things are fundamental in all the rest of your engineering maths, as you know, as we've been going this year. These problems have come up as in your knowledge. So anyone who wants to attend any of these, then that's fine. I think I'll make it open to everybody next time, so that anyone who wants to attend can do. Having said that, if you can't attend, then please can you just go and watch the recording at a later date. Whoever hasn't muted themselves, can you do that now, please? Thank you. Thanks a lot. Okay, by looking at, sorry, let me just go back to that page 1 second. We're going to look today at collecting like terms, expanding brackets, factoring, and algebraic fractions. Okay, so very simple starts to algebra. So let's look at like terms. Here, sorry, notes, so I don't miss out telling you anything. What we're doing here is when we say like terms, what we mean is terms that are separated by pluses and minuses here. Okay, so we consider this to be a term, for instance. If I see the variable x here, then any other term containing that variable is what we call a like term. So I've got 3 terms here which are like terms. Notice that when and I'm going to collect them together, that's what it says. Notice that when I collect them together, I'm collecting also the sign before the term. Okay, so 3x here has after it, but that plus does not belong to the term 3x. This 3x is a minus 3x. Remember that the sign immediately before the term belongs to that term. Okay, now this one doesn't have a sign, and often this is the case. You can see this one doesn't have a sign and this one doesn't either, because by default, if there is a minus, it's a plus. Okay, I have to write plus x, because it's just like when we write 4, we use 4, but we don't have to write the plus 4, they're equal. So like together the terms here, I'm going to have x minus 3x plus 2x. Okay, terms in here. So when I go together, I'll have minus 5y plus 2y. Note that all I've done is rearrange the order that the terms came in. You can see that color these x terms together would give me x minus 3x would be minus 2x plus is 0. So the x terms have actually cancelled out. I have no x terms. In my y, I collect them together. I've got minus y plus 2y. That's going to result in minus 3y, and that would be my final solution. I can't simplify anymore. So they're calling simplifying expressions, okay? Just aside, why these expressions and not equations? Because they're not equal to anything. So this is an expression, an algebraic expression where we've made it up with terms and or subtracting from each other, okay? Let's look at the next one. Actually, I'm just a minute there to stop and just go into chat and just ask everyone in chat, can you let me know if you are seeing the annotations?
Okay.
Use that.
It's not, yes, I can see all the annotations.
Lovely, thank you very much, Matt.
No problem.
Okay. All right, okay, that means if one person can see them, I'm guessing everybody can. Right.
Will they call minus third?
This one?
Yeah.
No.
What would that be full of third?
No, what you're doing is you're confused with an equation. I'm not trying to find the value of y. All I'm doing is collecting like terms to simplify the expression that was given to me. When I collect these like terms, all I'm left with is minus 3y. Okay, right. That's the next one. So here I've got a terms, 7a. I have no a terms. So to write it out, I can actually do that in my head, but I'll write it out just for completeness. So 7a minus 10a. And b terms. So I've got a minus 2b and a minus 2b. So minus d, minus 2. And I've got plus bc and a minus e plus minus 3c. Okay, collect together all my a terms. So these are terms. 7a minus 10a is minus 3a. My b minus 2b minus 2b will result with minus 4b. And minus 3c minus 3c will just cancel out and give me 0. So it will be my final result. Is 3a minus 4b. Let's move on to this one. Now, not just different letters, but I've got an x squared. So, well, my variable here is x, and my variable here is x, but my variable here is x as well. But that's not true. These are like terms. Is an x squared term, so it could be collected together with other x squared terms. So reading across here, I've got one more x squared term here. So collect those would be 12x squared minus x squared. Okay, x terms plus 3x minus 10x. And then I've got minus, and notice that there's no variable there, but they're number terms. So they're also like terms. So minus 4 plus 5. Together in my x squared terms then, 12x squared minus 11x, sorry, squared minus x 11x squared plus minus 10x is minus 7x, and minus 4 plus 5 is plus 1. Okay, I don't any further, so that's my solution. Okay, this will be available for you as well, so don't worry about keeping up or anything if I move on to the next page. Now, I just need to open so I can see. What I'm going to do now is I'm going to give you a 1 minute time in which to respond. Don't worry about getting it wrong. It doesn't matter. Okay? If you knew how to do this already and you were perfect at this, then you wouldn't need to be at it anyway. It's really not a problem. So I'll make the timer. I'm going to ask you to do it. So you've got 1 minute to work it out. Let me just move this and vote A, B, C, or D. So in chat, you just need to give me A, B, C, or D. Okay. So the question here: 9x plus 4y 2z minus z minus y plus 8x. The answer is one of these four here. I'm going to click that. I'm to me off. Okay, I'm going to stop it and move on because I can see that everyone has chosen. So let's just quickly check that. So 9x plus x is going to be 17x. 4y minus y will give me minus y. And 2z minus z will give me minus 3z. That's 17 minus y minus 3z. The answer is C. Well done, everybody. Everybody managed to get that right. Well done. Okay, the new skill, expanding brackets. For expanding brackets, what we need to, by the way, if you have questions about any of, I don't think anyone will do because you've got that right, but any of the multiple choice questions that I ask you, you type a question in chat and I can search for those at the end, or you can ask me the question at the end because I'll be here till 7 tonight answering questions. Okay, we're on expanding brackets now. So that is a bracket, okay? The bracket is another way in maths of saying that you want to multiply. Why have I written a bracket instead of writing multiply? Well, to multiply 5 with 2, I can just write 5 times 2. If I multiply 5 with 2 plus 3, then bracket looks like this. Now, there's a confusion of whether I want to add 3 to 10 or to multiply 5. Sorry, 5, 5. So we need the bracket, okay? So, going back to here, I've got terms inside the bracket, at least 2 terms, which is why the bracket exists. Outside the bracket, that needs to multiply with every term inside the bracket. Here I've got 5 multiplying with x. Well, 5 times 2 is 10, so that must be 10x. And I've got multiplying with 4y, so that'd be 20y. Do anything else to this, I can't simplify, and so that must be my final answer. No, it doesn't say expand and simplify, but simplify is a default. So where you can simplify, you should, and we'll see that in the next example now. Here I've got a term bracket, which is 3, multiplying with both of the terms inside the bracket. Sorry, excuse me. And another term outside the next bracket, which then has to multiply with both terms inside the bracket. So these would give me 3 times 2a is 6a. 3 minus b is minus 3b. 3a is minus 30a. And 3 minus 2b is minus 6b. Now, even though it doesn't ask me to simplify up here, it doesn't say expand and simplify. A default position that where you can simplify, you should. I can collect like terms, like we did in the last slide. So 6a minus 30a is going to be a result of minus 24a. I've got 3b and minus 6b, and that will result in minus 9b, and that will be my final solution. We'll look at this similar, but few extra little steps in this. So I've got a term outside which is not just a number. algebraic term. So it still has to multiply with everything inside the bracket, and so does this one, just like before. Times 2x. Well, 2 is 4, and x is x squared. 2x times 5y. That's going to give me 10xy. Now, if I the next one, in this expansion, I haven't had to worry about multiplying positives and negatives. I did have positives and negatives in the second example, but it didn't really affect me too much. Now, I have to be a bit more careful because it's a very common error that's coming up that people will make. Remember that this 4y term is a minus 4y. I'm multiplying it with this term. I've got a number multiplying with a positive number, and so the rules are, if you've forgotten, 2 positives multiplying together or 2 negatives multiplying together will always answer. A positive multiplied with a negative or a negative multiplied with a positive will be a negative answer. So here, a negative number multiplied by a positive number, so I've got a negative answer. And the multiple will be 4 times y times x. Now I'm going to write as 4xy. So all write the number first, and then the letters in alphabetical order, although it makes absolutely no difference. You've written y4x, it would mean exactly the same thing. Okay, it just looks unusual if you mess about with the order. Usually number and letters in alphabetical order. Okay, I've got minus 4y multiplying with minus 5y. This is minus times a minus. Lots of people would miss that. Okay, look out for negative numbers. Minus times is plus 420, and y plus y is y squared. Okay, simplify whenever I can. So for squared, there aren't any other x squared terms. I've got 10xy minus 4xy, so that's going to give 6xy. So they're both xy terms. They don't have the same variable, but they have the same group of variables, so they're like terms. And finally, only one y squared term, so that stays the same. Okay, so is the solution to that. On to a question for you now. I'll give you 1 minute. I'll just open it up and see what you have to say. Okay, the minute.
Do you want us sending this to everybody, or do you want it sent to you privately?
It's more, when I've done this before, it's more helpful if you send it to everybody because it helps people to make a decision if they're stuck between B and A or something. But if you want to send it to everybody, then don't. You know, it's absolutely fine.
I can send it to everyone. I just wondered if you wanted private or to everybody.
I mean, anyone who's uncomfortable about sending it to everyone, that's absolutely fine. But if fine, then that would be helpful to everyone else. Okay, here's your question. 5x, open brackets, x plus 4, minus 2, open brackets, x minus 8. Remember what I said about negative numbers. A minute to have a go and choose in, please, A, B, C, or D. I'm going to stop there. Thank you for your okay, so most people chose the solution D, and you are correct. The solution is D. I'll just show you 5 times x, 5x third. X times 4 is 20 minus times x is minus 2x, and minus 2 times minus a is plus 16. You've managed to get the plus 16, which you must have done if you've got sort of D very well, because that's a very, very common error. Okay, so that's plus 18 when I collect together the x's, plus 16. Okay, well done. Let's go. So now we're going to expand it again, but this time we don't just have a term outside of the bracket, we have two brackets, which in effect got two terms outside of the bracket. So just consider this as the bracket, like I had last time. I could pretend that this 2 didn't exist, so I'll work that out in a minute. If 2 didn't exist, I'd say x times x and times 4 would give me a result of x times x is x squared, and x times 4 is plus 4x here. Okay, just rub that bit out. So does it go this plus 2? So what I do now is I need to also multiply by the second term. So what I've done is I've just an x and got my two answers there from expanding. Now I multiply by the 2 times x is 2x, and 2 is 8. Okay. Now this everything is pluses, so we don't need to worry about our rules about plus. When positives and negative numbers multiply each other. But think about that. You need to think about some of the other questions down here. I'll finish this one off. Because we have two x terms, then collecting those together would give me a solution of plus 6x. I can have a go at the next one. So 2x times 3 and 2x times minus 2. So just ending, I have this term, first of all. That gives 2 times 3 is 6, and x times x is x squared. 2x multiplying with minus 2, so that's 4x. Okay, now I have 3 times by x, that's minus 9x, and then I've got minus 3 multiply minus 2, so that will give me a plus 6. Collecting two x terms together here, that will give me minus 13x plus 6 as my final solution. Okay, and one more here. 2 times 7x minus 5. Factorising first. So 7x is 14x squared. 2 times minus 5 minus 10x. And I've got 6 times 7x, so those two plus numbers, so that must be a plus answer. That's 2 plus the x. I've got plus 5 times minus 5, so plus minus, I can see would give me a minus answer. That's minus 5. Collecting two x terms together here in the middle, and up with 14x squared minus 10x plus 35 would give me plus 25x minus 25. I can't simplify, so that's my final solution. Okay, let's give you a question. So, in which cut this answer and vote for A, B, C, or D. I'm going to the timer now. can tell you that the correct answer, I saw several people show me D in their chat, in the chat menu, so well done. So very quickly, an explanation. So x times is squared, x times 10 minus 10x, times x minus 4x, minus 4 times minus 10 plus 40. Together the two x term in the middle will just be, simply forgive me, 14x plus 40, which is D. Well done, everybody. Okay, let's do factorising. Now, most people will, if they do stuck, will be stuck with factorising. So we'll start off a bit simpler. And factorising is important because it helps you with algebraic as well. Without understanding factorising, then you will with algebraic fractions that are everywhere in engineering. So when you're asked to factorise an expression, what I want you to see the expression as being made up of its factors. Okay, so what means take the common factor and write the rest in the brackets. So let's go back a few pages. It's like going back to write this form. Okay, so find common factor. So having been given 10x plus 20y, you would 5 was the common factor. That 10 is a common factor. You could have took 10 out as well. 5 is a common factor. Okay, so this is the factorized version. It's not factorized because another 2 is common as well. Okay, so let's go back and have a look at our question. Just imagine that 12xy, and if I look at 12, the number 12 and the number 8 and the number 3, they're common factors for 12, 8 and 3. So I don't need to split 12 down into 2 times 6 or 3 times 4 because none of them are going to be common. Okay, so the 12xy I can see is just made up of 12 times x times y. The x squared y, I can split that as x times y. Once I write this out, you just need to see it like this. You can write it out if it helps. And this term here would minus 3x times y times y. But when I've expanded it like this, I now begin to see what are the common factors. There are no common factors in these numbers here, but there are common factors in the variables. I have an x in each of these, and I y in each of these. The term xy is common to all of them. So take xy as the common factor. Back to being able to see it like this, I see that if I take out xy as a common factor, I'm left with 12. And this is a plus here, so this is a plus here. In the term, if I take xy as a common factor, I'm left with 8x. And if I take out xy as a common factor, I'm left with minus 3y squared. That's inside this bracket that is common to any of these. So I've removed the common factors. So fully factorized expression now. Okay. Now, this will be different. So when you're factorizing a quadratic like this, we have a quadratic term, an x, so a quadratic meaning power x to the power 2, and we have an x term and a number term. We know that 6 factorized into 2 brackets. We multiply, we now have to multiply 2 brackets, we just did that. I know that we have to have an x times an x to give us this x squared here. I know that the numbers here have to multiply to make 6. So I need to work out what numbers do I need to write in here that multiply together to make 6. I'm looking for factor pairs of 6. So 1 times 6 is a factor pair of 6 because that multiply together to make 6. 2 times 3. Okay, so 2 and 3. Now I now need to consider which of these factor pairs, when I put together, will also make 5. Now, 6 and 1 could make 5 if 6 and a minus this one. But this one can't make +6. So therefore, that cannot be the factor power I need. For +6, I'm either going to have 2 plus numbers, or 2 positive numbers, or negative numbers. And in this, I have a +2 and a +3. I add those together, I get, and when I time those together, I get 6 of the numbers I'm looking for. When I time together, I get 6. When I add them together, I get 5. And that's quite long-winded, but actually mentally, because the numbers are usually quite simple, very quickly, and say these numbers must be 2 and 3. Now, the order that I've written them in makes no difference whatsoever. They still make 6, and they're still going to make 5 when you add them together. So it's +3. And that's easy because these are all pluses, so therefore these are pluses as well. In the next, we have some negatives, so we have to do a bit more pokery with our numbers. So it's a quadratic, so we know that it would factor brackets. We know that if we want to make x squared, we have to have an x here, so that x times x gives us the x squared. Now I'm looking to make the number 9. Let me just come first of all. So factor pairs of 10 would be 1 and 10, or 5. And one of these numbers has got to be a minus. So -1 times 10, that would make 10, that -10. Or 1 minus 10, that would make -10. So it's 1 is plus and 1 is a minus. The combination of these numbers will also make, when I add them together, will make -3. And I can see a way that I can't make the figure out of 1 and 10. So it must be made out of 5 and 2. And if I want it to be -3, I'm going to have more negative and less positive. So -5 plus 2. Just checking that. I've got 2 times by -5. That's -10. That's what I wanted. And I've got 2 added to -5. That's just -3. What I wanted. So those numbers are correct. So it's x plus 2 and -5. All right, let me ask you a question now. Okay, give you 1 minute in which to out and put an vote B, C, or D in your chat, please. Okay. So I'm considering pairs of 15. I've got to also make a +2. I can see that that's going to be +5 and -3. So that's x plus 5, x -3. Okay. You don't need to write this out. You can do that mentally, but by all means do if it helps. Okay. It really doesn't matter whether you do or you don't. Question: why doesn't it matter what these are written in? Are they equal? You can tell. Very good, Matt. Very formal there. Okay, I was just going to say it's a product. and the order that you times things in doesn't matter, but Matt has trumped me there and told me that multiplication is commutative. Thank you. Okay, so it's just like having two numbers, times 2 times 3, sorry, 2 times 2 is the same as 3 times 2. It doesn't matter which order you multiply these in, okay? Okay, there are algebraic fractions. So I was talking about being able to see terms as factors, particularly important in algebraic fractions. When you're asked to simplify, what they mean is, right, okay, it's gone a bit weird. Cancel common factors. Okay, so factors is going to simplify this fraction into something simple. That's what we need to do. So I need to think of this numerator and this denominator in expanded form as of its factors. You can see that this would be 5 times x times y times y. Those are the factors making up this expression. And I can see that in the denominator I've got 5 times x times y. And those are all common factors. So 5 in the numerator with a 5 in the denominator. Got an x here, a y here, and a y here. So left with, I've got a denominator there, didn't I? This is 2 times 5. That's my mistake. Okay, in the numerator, I'm left with y. Denominator, I'm left with 2x. If I had had 5xy over xy, well, what's happened there? What would have been a 2? That y would have come out, and the x would have cancelled out with one of the x's there. I can see that I've left with an x. What am I left with in the numerator there? Anyone tell me? It's all that. What am I left with? Yeah, there's a 1 left, and he's right, because what you're doing is you're saying, well, it's 0. That was my point. But if you sort everything out on the numerator, you're still left with a 1, okay? There's 1 of everything, so you could actually say 1 times all of that. It'll have the 1 left over. So when you sort everything out, please remember it's not a 0. And the next one, so 27 I'm going to see as 9 times 3. A cubed is A, together of course. B squared is B times B. E to the 5, 1, 2, 3, 4, 5. All over 9. A, 2, 3, 4, 5, and a C. So sim cancelling out common factors. 1, 2, 2. And I've got 1 b here, which will cancel with 2 b's here. I've got a C and a C here. In my numerator, I'm left with 3a c to the 4. A c to the 4. Denominator, I'm left with b. Okay. I don't have to write this expanded way. It's an explanation of what's happening. But it gets a bit messy. I'll show you, and you can kind of just be careful because it gets a bit messy. So 9 into 9 go 1, so that's just a 1. 9 in will go 3. A from that will cancel with from that, so I'm just going to be left with an A. 2 B's making these words will cancel with 2 of them from there, so I'm going to end up with a 3. Will cancel with 1 C from here, so I'm left with a 4. I have 3a c to the 4, which is what I had here. B cubed in the denominator, but it looks quite messy. So just careful when you're doing that, because there's lines and small numbers everywhere. Okay, write it out in full to check, then do so. Now, so I have to simplify. So if I'm told that I have to simplify this fraction, I'm going to know that I'm going to have to factorize this to simplify it, because this is a quadratic equation. Okay, common factors. The thing I've got down here is x plus 1. I cancel out x with an x up here. Okay, so I can see that the numerator could be factorised into x1, x plus 2, and that I would have an x plus 1 in the numerator, do x plus 1 in the denominator, and so it simplifies nicely into x plus 2. Okay? The way quadratic, either in the numerator or the denominator, if you simplify, then what you've got to do is factorise. Okay, you're simplifying by a common factor of a bracket rather than a term. Okay. All right, you to go out. So what the answer and vote for A, B, C, or D. Simplify this fraction. Okay, and most people there I could see were telling me that their correct answer was D, and they were correct answer is D. Let's click it to show you how. Shorthand rather than writing it out in full. It'll cancel with a 6 from here, so I'll be left with a 1 there. So 6 is 1, 6 is 12, go 2. Okay, here we'll cancel with one of the x's here, so I'm still going to have 2 of them left over. 2 y's from here, we'll cancel 2 of them from here, so I'm still left with 2. 2 z here, we'll cancel with z's from here, so I'll be left with z's in the numerator. So this gives me 2 is my number term. My term is x squared in the numerator. No y terms left. My z will be z cubed. In the denominator, I don't need to write that. No x terms, no z terms, to y squared. The correct answer was D. Okay. Something else that you have to often do with algebra is you have to them as a single fraction. Okay. So let's just think about numbers. If I had 2/3 added to 1/5, what I do is find a common factor. So I can see a common factor of 3 and 5 would be, common multiple of 3 and 5 would be 15. Now, taking the 3 into a 15, I multiplied it by 5, and so I'd have to multiply the top by 5 as well. Okay, portion the same. So 5 to make 15 in the denominator, 2 times 5 to 10 in the denominator. 5 has become 15, so that must have multiplied by 3. So the numerator must also multiply by 3. So that makes 3 in the numerator, 15. Now, it's really the same here. The same logic applies to great fractions because they just stand for numbers. Okay. Common factor will be, common multiple for 7 and 3 would be 21. So I'm going to write my common multiple here. 21, this has had to multiply by 3, so therefore this will also multiply by 3. So 5 times 3 is 15x. Okay, this has had to multiply 7, and so 2x in the numerator. That means I'm on not 2x anymore, but 4x. Okay, got 15x plus 14x over 21. So that is now 29x over 21. Top heavy doesn't add to. Okay. One, a common factor this time would be 6. Okay, they're both common pool. Sorry, I keep calling it a factor. Common pool of 2 and 3 would be 6. Those, you might 30. Going to make your calculations much harder because your numbers are bigger. So the lowest common multiple is always a good idea. Many times what did I divide 3 by to make 6? So I multiplied it by 2. So therefore I multiply the top by 2. Now if I'm multiplying a whole terms, not just one term, by 2, that's when I need to write a bracket. So I multiply by 2 by writing it like this. Now the 2 had to be multiplied to make 6, so therefore this whole section must also be multiplied by 3. Here, so I must replicate that minus here, so it's minus 3 times whatever that term was. I use some of the things that we learned here, so 2 times 2x and 2 times 2. So that's x plus 4 minus 5x minus 3 times minus 1, so minus 15x plus 3, or x. Okay, and 4x, I'm collecting like terms now. So 4 is 15x is minus 11x, and 4 plus 3 is plus 7, and that's all over 6. And that's my answer. Okay, now this time we've got not numbers in the denominator, but terms. So we've got variables introduced here. So factor here would be 20x. I don't have to do x squared. I could. 20x is 20 squared is also a common multiple of these two denominators, but x is a simpler multiple because I can make 5x into 20x by just times in by 4. So times top by 4 as well. The denominator to change the numerator as well in the same way. So 4 times that numerator is here, so there must be a minus here as well. I have to multiply by 5 to make that new denominator. Multiply the top by 5 as well. So that's 5 2x plus 5. Okay, and multiply just like we learned. So we expand the brackets. So 4 times 3x, 12x. 4 times 1 minus 4. Minus 2x minus 10x. Minus 5 times plus 5 minus 25. Or 20x. Okay, collecting terms as we learned earlier. 12 minus 10x is 2x. And 4 minus 25 is minus 29. Or 20x. Okay, so let's see. Do one. So just my pen into a pointer. And you've got a minute, so you'll have to be fast. I'll read it out to give you some extra time. We've got writing the same fraction, x plus 2 over 5 minus 2x plus 3 all over 3. Okay, off you go. Just going to show you. Oh dear, Matt. Right, we actually get the right answer, which is really good because this is harder and involves all of the skills that we've learned earlier. Okay, so 5 and 3 would have a common factor of 15. That means it's been multiplied by 3, so therefore the numerator gets multiplied by 3. A minus in the middle, 3 must have been multiplied by, so therefore the numerator gets multiplied by 5 as well. Expanding this would give me 3x plus 6 minus 10x minus 15. It's all over 15. I'm collecting like 3x minus 10x is minus 7x. 6 minus 15 is minus 9. That's all over 15. That's minus 9 all over 15. That's answer B. Okay. So I'm just going to move to the last page. You can now, what I'm going to do is just read the slide, then I'm going to bring my worktop with you so that I see chat in a bigger window, and then you can ask questions. Be here until 7 p.m. Or even later if you need to ask more questions, that's fine. If you want to talk to me and ask questions using the talk feature, then unmute yourself and you can ask questions that way as well. If you need to go back to a particular slide and do that again, or show you something in particular, I'm quest because most of the solutions that were given to chat were correct. I'm hoping that this is something that's fundamental and easy for you, and that this is a basis for you to work on. Next week, though, we'll be looking at equations, and we're looking particularly at solving linear equations, that's the simple form, and also quadratic equations. So if you wanted to attend that, then that would be next Thursday, same time, 6 or 7. We'll send an email to everybody on the course, and anybody who wants to attend can do. A record session will be made available to you. Send a link and I can send you that. So you'll be able to go through this at your own pace if you need to at any time in the future. Okay? I'm going to bring my desktop, so let's just see. So I can see chat now. So if there are questions, you can now ask me in chat. I'm going to unmute everybody so that if you want to. Hello. Okay. I can only assume that until it's learning. Okay. Thank you, Will. That's helpful for you. And you can learn you okay. Thank you. Oh, okay. Myself on mute there, just because say goodbye to Chris, who's just been sitting and helping me. Thank you everyone for attending, and I'll just wait for another 5 minutes until just make sure that anyone has a question can ask it. If you use your microphone function and ask it, use the talk feature, that's fine. Just use the chat feature, and that's fine as well. Okay?
Yeah.
Oh, hi.
It's just a very simple question. Is there, instead of recognition thing, it's a very easy way of recognizing how to factor out quadratic, because I've been working on that rule that you showed us just there with the 2 nice multiply to equal that, and I add together to equal that, and sometimes I'm getting a little bit hang on, right one. And
yeah. Hang on, let me just go back to
because second order differential equations that we were doing. Working on those all weekend. Obviously, some of them you can factorise, some you have to use a quadratic. And I myself pulling brackets on so many different occasions, and then looking at your solutions and realising, oh my God, there is, you can factorise it out.
Well, what happens is that in questions to answer by teachers, what will happen is that the numbers will be easy to spot. It can be factorised easily. Very quickly, you should be able to see by looking at the number whether you can do that mentally. You can do that mentally. You know, we can see this page, can't you, Matt?
Yeah.
Okay. So if you look at this number here, I can see straight away that 6 is made up of 1 and 6 or 2 and 3, and I can see 2 and 3 is going to make 5. It's a simple step just to do that. Here in this number here, minus 10, I can see that 10 is made up of 1 or 2 and 5. So any choices to work from, and I can see 2 and 5 are going to combine to make a 3. Actually, I'll just have to have a bigger negative number, so minus 5 plus 2. So factorise quadratics. Where we factorise, they always be with simple numbers. Where not simple, it's not going through. If the here was plus 60, there are many factor pairs of 60, so many things going to 60 that it's going through every single one, and let's spot it immediately, chance. You could write a list of factor pairs here, and you're checking against each of these factor pairs to see which one of those is making that number in the middle. So it should be numbers that are very straightforward and easy to combine. Well, then use the formula. The way is, it gets easier with practice.
So you mentioned a formula. What's the formula? What? And the quadratic
formula. Yeah. Okay, so the quadratic formula. Let's do it. Hang on. Let me rub out basics and space.
I sound really stupid now, because even when I used the quadratic formula, I got to a pair of whatever they are, alphas, gammas, whatever they are.
Yeah.
But not the right ones when you use the factorising solution.
Oh, right. Do you have that actual question in front of you? Could have a
no, I don't.
No.
If you're tomorrow, then I can bring it in tomorrow. We can take a look at it. But
Not actually, Matt, but we can set up a next meeting and talk about it, even if it's just for 5 minutes. It's very easy to do. So I can email you, and sort of, if you tell me when you're free, I can sort of set up a time and we can just have a quick chat and go with it.
I imagine it's probably just a naughty mistake that I've made.
So do you want me to show you how the quadratic would work with these two? The quadratic formula?
No, it's fine. I'm absolutely comfortable with the quadratic. It's not a problem at all.
Okay.
It's just I need to back over the working and see if I've just done something stupid.
Oh, okay. Well, if you want to, you can send me like a PDF of that, and I'll look over that and annotate it and send it back to you. Okay, no problem. Okay, any other questions? Let me just see who's around.
No, I thought that was really good.
Oh, do you? Oh, really, really great news, because it's hard to tell because I'm just sat here and
my lad's here as well, and he's enjoyed it as well.
That's good. We can next
No,
week
well-
then. I'll expect him there.
He might not, but I'm going to get that from him. But now I thought that
Oh, good. Thank you so much. Thanks for attending as well.
Thank you for taking the time out, Shaheen. I learned from you.
No, any time.
I was putting on. It was good.
Great. Thanks so much for your feedback. Really appreciate it. Thanks.
Come off.
Okay.
Yeah. Take care all.
Okay. Bye bye.